Hi again. So in this video, we're going to take a look at how to solve for x again, or basically solve for a variable or an unknown. And the equation that you're going to see is pretty much going to be in fractional form, okay? So let's take a look at our first example. So let's say you have k divided by 5 minus 2 over 3 is equal to 1 over 2. Okay, so the best way to go about this equation is, so there are a couple of different ways to go about it, but I'll just show you one of the possible ways. So what you want to do is you want to take the 5, the 3, and the 2, basically since everything is a fraction, you just go ahead and take all the 5, the 2, and the 5, the 3, and the 2, which is the denominators, and find the lowest common denominator. So in this case, 5, 3, and 2, since they're all prime numbers, therefore you just multiply them out, and that gives you the lowest common denominator, which is 30. All right. Now, once you know the lowest common denominator, simply ask yourself, well, how many times does 5 go into 30? Well, it's going to be 6, right? So multiply the k with the 6. And then ask yourself how many times how many times does 3 go into 30? That's 10 times. So 10 times 2 is 20. And then 2 goes into 30 15 times. 15 times 1 is 15. And watch what happened. When I do that, the interesting thing is I just get rid of all the denominators. Okay, so even though I have 30 out here, so normally if you're trying to add or subtract fractions, you keep the denominator. But when you're doing an equation, you can actually get rid of the denominator. And the reason behind that, if in case you're curious, is because think about it. If you were doing this the usual way, then you would put this over 30 and this over 30. But because you have 30 on both sides, essentially, if you multiply both sides with 30, you get rid of the 30, right? So, and this always plays out in the exact same way when you're dealing with an equation, okay? So you might as well not even bother with that step and just go ahead and write 6k minus 20 is equal to 15. All right, so now this becomes a easier problem to solve. So now I'm just going to go ahead and add 20 to both sides. So I get 6k is equal to 35, and then k is equal to 35 divided by 6, excuse me, which is equal to, you can leave this as an improper fraction or convert it to a mixed number, which would be 5 and 5/6. All right, let's try another one, okay? Now this one, the next one is going to be look a little different. So I have x over 2 minus x minus 3 divided by 7, and that is equal to -1. All right, so now the 1 doesn't have is not a fraction, but you can put that over 1 if you want to make things simple. And then lowest common denominator for 2 and 7 is going to be 14, right? That's your lowest common denominator. So, well, 2 goes into 14 7 times. So multiply the x with 7 and drop everything else for the first fraction. The second fraction, 7 goes into 14 2 times. So multiply the top with 2. And then the right-hand side, because 1 goes into 14 14 times, so you multiply the -1 with 14. So that makes it -14. All right, now let's go ahead and simplify. 7x minus 2x. When we distribute the 2, that's 2x, and then -2 times -3 is positive 6 is equal to -14. All right, so what's interesting to notice carefully, you're multiplying the -2 with the -3, and when you do that, the sign changes. A lot of times students will forget to change the sign, and that kind of is the big error in these kind of problems. So always watch for the signs, okay? So let's combine the x's. That makes it 5x plus 6 is equal to -14. Okay, and then now I'm going to go ahead and subtract 6 from both sides. So I get 5x is equal to -20. And then I divide both sides by 5. So x is equal to negative 4. And there you have it. Okay. Okay, let's try another one that's going to look, again, it's going to be a different kind of problem. So let's try this one. So let's say we have 3y minus 1 divided by y minus 2 is equal to 5 divided by y minus 2 plus 1. Okay, so see this problem in comparison, because you have y minus 2, if you compare it to this problem out here, see, you don't have the variable at the bottom. Even out here, see, there's only numbers at the bottom. So now we're kind of diving into the realm of you actually have a y at the bottom as well. So what do you do? Well, the key is to take this entire thing as one unit, okay? And luckily for us in this problem, there is no difference between this and this, so therefore that is literally the LCD. So the LCD is equal to y minus 2. So in that case, well, y minus 2 goes into y minus 2 one time, so therefore the 3y minus 1 comes down, we get rid of the denominator. Same thing with the 5. Since y minus 2 goes into y minus 2 one time, it's 1 times 5, which gives you 5. And then this one out here, that goes into y minus 2 times, right? So plus 1 times y minus 2. Okay, now let's simplify. So 3y minus 1 is equal to 5 plus y minus 2. Let's go ahead and combine the y's. So we get 2y minus 1 is equal to 5 minus 2 is 3, right? Let's add 1 to both sides. So we get 2y is equal to 4. And then to isolate the y, we divide by 2. So y is equal to 2. And there you have it. Hopefully that made sense. Thank you for watching.